Okay, last section for test 4. So on these, just remember if the roots match up, we're going to go ahead and multiply across. So we'd have 16 times 4 there. So that's going to give us the cubed root of 64. And then the cubed root of 64 is 8. Here we're going to go ahead and multiply across, so 3 times 5, so we'd have the square root of 15x. That does not simplify, because there's not a square root of 15. There's a square root of 16, and there's a square root of 9, but there's not a square root of 15, so that would be your answer. Here, we're just like we were multiplying a normal fraction, 5 times 7 and x times y. So the square root of 35 over xy. There's a square root of 36, there's a square root of 25, but there's not a square root of 35, so we're going to leave that one there. Here, square root of the top and square root of the bottom. There's a square root of 49, so we're going to have the square root of 3 over 7. And there's not a square root of 3, there's a square root of 4. So we leave that one as is. Square root of 6 over the square root of 25. The square root of 25 is 5. There's not a square root of 6, so y'all couldn't see that. We'll leave that one as is. And you can always check these on your calculator as well. So the top, they start off with the cubed root of 9 and the cubed root of 64. There's not a cubed root of 9, there's a square root of 9. But the square root of 64 is that 4. So we'd leave it like that. On the bottom, we have the cubed root of 9. Once again, there's not a cubed root of 9. And then remember when we're doing exponents and roots, divide, so 6 divided by 3 is with that x squared. Here, cubed root of 2x, I can't divide 1 by 3, so I leave it like that, because that tells us to use our radicals. But on the bottom, the cubed root of 81y 12. Cubed root of 81 is 3. Wait, let's think about it, because 3 times 3 is 9 times 3 is 27. So we're going to simplify this one actually. So I'm going to break this apart. I have my 27 here, and then I'd have my 3 here, because 3 times 27 is 81. And then 12 divided by 3 is that 4. Here though, the cubed root of 27 is 3. So I'm going to have the cubed root of 2x over 3y to the 4th cubed root of 3. And let me check my calculator real quick. I do believe it'll do that cubed root of 81 for us. And y'all can probably type these calculators in. I know TI was doing you can go download your calculator for free kind of thing. So before I do that, I need to type 3. So now I have it up in that cubed root area, and then I'm going to type in 81. Oh no, I thought it would simplify that for me. Well, we'll work on them as we go. Here we have the square root of 13x squared over the square root of 9y squared. So we can take the square root of 9, and that's 3, and the square root of y squared, y. There's not a square root of 13. So I'm going to have my x, because there's square root of x, but the square root of 13 and stay under the square root. Okay. Here we can simplify these. When you're doing these, I want you to look at that paper I printed out that had all the square roots on it and see if there's a square root that goes into this. So I always start from the bottom and go to the top. So 4 does not go into 50 evenly, and I'm saying 4 because 2 squared equals 4. 3 squared equals 9. 9 doesn't go into evenly. 4 squared equals 16. 16 doesn't go into 50 evenly. 5 squared equals 25. 25 does. So I'd have the square root of 25 times the square root of 2. Because 25 times 2 is 50. Then I know that the square root of 25 is 5. So it'd be 5 times the square root of 2. On this cubed root of 16, I'd start with 2 cubed is 8. Does 8 go into 16? Yes. So I'd have the cubed root of 8 times the cubed root of 2. And then I know the cubed root of 8 is 2, so I'd have 2 cubed root of 2, because these simplified. This simplified to this, and this simplified to this. Alright, here we go on square root of 28. So I'm going to use these because it's square root, so I'm going to use squares. Does 4 go into 28? Yes, 4 goes into 28. 7 times, right? Times the square root of 7. There's not a square root of 7, but the square root of 4 is 2. Alright, here we go. Square root of 49 is 7. This is an odd number, so on these, 2 goes into 7 3 times, and the remainder is 1, so 1 has to stay under it. So right here, 3 goes into 6 evenly 2 times, 3 goes into 5 1 time, and the remainder is 2. Square root of 15, 2 goes into 15 7 times, but that's only 14, and there's a remainder 1. Square root of 81 is 9, 2 goes into 6 3 times, 2 goes into 3 1 time, with 1 left over. The 7th root of 75. I have no clue. So 7th root of 75. Not thinking that's a real number. Okay. I don't even know if I can simplify that. That's 2 to the 7th power. 128. Nope. Okay. So the 7's going to stay under. So 7 goes into 34 times, because that's the 28. And so we have a remainder. The 75 stays under, and then we have 2 that's still left in here. And we have to put that little 7 there. Don't forget your root. Like I did right here. Y'all didn't see that right here. Since I had the cube root there, I needed to put a 3 here, and I missed it earlier. But that's a square, square, square. So this one's a square root. So the square root of 81 is 9. 2 goes into 11 5 times. And then we're going to have leftovers over here. There'd be 1 left there. 2 goes into 7 3 times with 1 left over. Cubed root of 27 is 3, because 3 times 3 is 9 times 3 is 27. 3 goes into 12 4 times. 3 goes into 18 6 times. No remainders. Use the quotient rule to divide, then simplify if possible. Okay, so 2 squared equals 4. 4 goes into 12, so I'd have the square root of 4 times the square root of 3 over the square root of 6. And 4 doesn't go into 6 evenly, and 4 is our smallest square because 1 squared is 1 and 1 goes into everything. We don't deal with that. So we'd have 2 square root of 3 over the square root of 6. Cube root of 108. Joy. So 2 cubed equals 8, and I'll go ahead and write a few. 3 cubed equals 27, and 4 cubed equals 64. Let's see. So 108 divided by 8 equals 13.5, not even. 108 divided by 27 equals 4. That's what we're going to use. So we're going to have the cubed root of 27 times the cubed root of 4. And then this doesn't simplify, but we have the cubed root of 4 under it anyway. Now, what happened here is the cubed root of 4 divided by the cubed root of 4. Anything divided by itself is 1. So these two divided by itself is going to be 1. So the cubed root of 27 is 3. And that'd be it. Okay. Let's see. Does 8 go into 162? Nope. It does 64. Nope. Maybe 27. Okay. So I was using these same numbers right here to see about this top one right here. So we're going to go ahead and break that up then. Oh no, it's the 4th root. I was using cubed roots. Just kidding. So we have 2 to the 4th, 3 to the 4th, and let's do 4 to the 4th. So 2 raised to the 4th power is 16. 3 raised to the 4th power is 81. 4 raised to the 4th power is 256. That's a bust, so I'm not going to do that one, because 256 is bigger than our 162. So 81 times 2 is going to be that 162. So remember, I have this 6 here, and then I'll have the 4th root of 81 times the 4th root of 2 all over that 4th root of 2. Same thing's going to happen here. Anything divided by itself is 1. And so I'm going to have 6 times the 4th root of 81 is 3. So 6 times 3 equals 18. Okay, what do we got here? So we have 7 times, we're using our cubes again. 8 goes into 45 times. So I'm going to have the cubed root of 8. 3 goes into 4 one time, so I'm going to bring that m out over here. Of 5m. So here, these are the same thing again. So anything divided by itself is 1. Cubed root of 8 is 2, so I have 7m times 2, which is 14m. That's all for 7.3. Okay.